Okay, this might work now. Let's see. Okay, let's see. How about now? Am I streaming at all? It's very, very strange and odd, this situation. Yes, there I am. Yay! Hi. Okay, good. I think I'm streaming. Fantastic. Okay, and hopefully you can hear me. Let's just check my... oh, that says still the same. Okay, try going back to the page and see if there is a live stream there. Okay. Oh my gosh. Oh my goodness. So this is very frustrating for your host. And I'm doing it in this one. So there's the chat. Okay, very good. There's somebody there and they see me. Fantastic. Okay, now let me put this over here. Close this window. Boom. And awesome. Okay, hi. Good. This is now working. I don't know what the heck was happening, but well, one thing I noticed was that they seem to have changed my stream key. So I use this software to stream with, and there's all these settings, and you know I do this every time, and so I thought that I had a persistent stream key. Apparently, I did not. So that's it. So I'm going to look over here occasionally to my other screen where my chat window is, and I'm going to just chat into there. Is my voice synced with my picture? It's always interesting to know. Anyway, so the topic of today's video is actually, I have someone on the line who actually asked me this question earlier. We have an earlier chat, and then now she's joining me now, which is fantastic. And she asked me this question about how technical do you have to be? And in fact, I had just finished talking to a coaching client yesterday about how technical you have to be a successful product manager. And my feeling is that you don't have to be that technical. You have to be somewhat technical, but there's some things that you can learn that will help you. And there's ways that you need to recognize that you're not technical, and that is actually a benefit to, you know, some aspects of the situation. So I keep looking over to my other window. I apologize about that. I've got to figure out how to get that to work. So anyway, so the topic of the talk today is this: how technical do you have to be? And I do have a slideshow about that. So I'm just going to go into my PowerPoint now. The person who's watching here also knows that I have some recommendations about how to make PowerPoints and how to make your PowerPoint 10 times better. And I did not manage to do all the steps in my PowerPoint, in my guidelines of how to make your PowerPoint 10 times better. So this is going to be maybe only 2 times better than it could be. Actually, it could be a lot better, but it's not going to be that good. But this, as we discussed, this is a topic that I know something about. And so I thought I would just share that. Now, let me just quickly go to the slide share. And really the most important rule, I think, for working with devs and for being a non-technical person working with devs is that you really have to understand and be empathetic to how devs are different from product managers. And there's a whole bunch of different things associated with these differences, and I'll go into them in a little bit more detail. But the other thing is to recognize that they're human beings, they're doing their best, and they, just like other human beings, and I know sometimes it's hard to believe that they are human beings, they really want to be happy, they want to be successful, they want to be productive, even though it seems like it takes them forever to develop things sometimes. And then sometimes you're just really shocked at how fast things come out. And of course, they want to be appreciated. So they're just human beings, developers, and so they have a lot of these same needs and desires that we have. Now, this is not really related to the empathy part, but it's just an example of sort of part of my story of transitioning, of getting from being, I started as a tech writer, and I knew a little bit of programming, and I did some technical writing for some sort of technical computer products back in a long time ago. We won't say how long ago. And I was really writing things like the programming manuals because I knew how to program in a sense. And I'll talk a little bit about that, a little bit more about my ability to program versus what real programmers have to do in terms of writing programs that become products. But I'd been there for quite a while. I was talking to one of the developers about a particular term that had started to be used quite a lot that I was a little bit confused by. I didn't really know what it meant. And so and the term was the repository. And so I asked the guy, and it was like, well, so Oracle's releasing this repository. And I thought, well, what is a repository? And we'll get to in a little bit what the repository actually means. But what was interesting to me, and I still remember that it was such an interesting learning moment for me, is that the repository is a concept. It's not a thing. The repository is where you put your data. And this was a point where the penny dropped for me, that there was a whole different set of things going on in programmers' minds and things that I didn't understand, that were conceptual, that I could start to get a grasp on, and it would help me be a better communicator with the developers because they were throwing around terms like this. Now, I knew that I didn't really need to know the details of programming in the software, although sometimes they would expect me to. But what I did need to know was things like what the repository meant. And so it's just something that has stuck with me for many years, this conversation about the repository. I remember the developer, Peter Christensen, very clearly sort of explaining to me, he was a very nice guy, but super smart. But he was explaining to me very kindly that the repository is not a piece of product. It's a way of using something to store the data. And it's just a generic term. And it was sort of a great learning experience for me. So I really, I just still remember that. And I don't know if that's a very important story, but it's just a story that has stuck with me. So I'll talk a little bit more about other terms as we go through. So let's go back to this idea about being empathetic for developers as a product manager. And some of the things that you need to know, or that are valuable to know, are things like, what are the real differences? Why are some people good at being developers and some people wouldn't make good developers but make good product managers? And interestingly, there's some crossover between those. Now, I personally don't think I would make a good developer for some specific reasons. I look at the developers that I work with, and I know that they're very different from me in terms of their personalities. So I realize because I didn't practice this, going back to that other topic that I mentioned at the beginning, I am missing a point on this slide. And the point is right here that one of the really big differences between people that are good at product management and people that are good at development, one of the big differences is attention. I don't know if attention's the right word. Ability to be distracted, or willingness to be distracted, or willingness to change to context switch a lot. So an ability to context switch versus a desire to not have to context switch. And let me explain what I mean by that. As a product manager, you probably know that there's 10 to 15 things that you have to sort of think about per day. All of them represent a context switch of some kind, and they can go from a big picture thing to, sorry, I hit the mic, from a big picture thing to a small thing, and they can be about some topic over here. They can be a marketing topic, a sales topic, a technical topic, all these different things. And our brains are always context switching in that way. As product managers, that's just part of our job. There's like all these things that we have to be constantly context switching about. Now, developers, as a rule, really, really hate all that context switching. They want to be able to concentrate on one thing at a time. And typically, the way that you hear them describe this is that being a good programmer involves concentrating on a particular thing for many hours, often days at a time, and getting a mental model of the entire structure of what they're building into their head so that they can then code it and recognize when things are going wrong and where things have to connect and things like that. So for a developer, context switching is really, really bad. That's why developers hate going to meetings. Now, sometimes for me as a product manager, I feel like, wow, I've got an hour where I'm just talking about the same thing for an hour. That's like extra long for me. Can I even concentrate for that long? Whereas for a developer, a meeting represents, I have to drop all that stuff that's in my head, the whole mental model. I have to go do this to this other meeting that's probably not going to keep me very engaged. And then I have to leave the meeting and go back and try to build up that mental model again. So that's a really significant difference between product managers and developers. And typically, at least for me, I guess I can speak for myself, I would not like that thing of where every day all I did was think about one thing at a time, or maybe for a whole week, think about one thing at a time. I like this doing lots of different stuff. That works for me. So that is a very big difference. And you can see some other aspects of that you can see that showing up in other aspects of sort of the differences between product managers and developers. Developers tend to be much more detail-oriented in a very specific way than product managers. We tend to look at very big pictures. When we look at a big picture, we easily edit out things from that picture that we don't think are important. Whereas developers, they don't do that in the same way. They don't edit out things. They might be willing to if you guide them to do that, but they don't do it by nature. So for example, I always like to give examples about, sort of technical things where we might decide to what I call stub off some functionality. So for example, imagine you want your developers to create an input form for names. And as we know, there's no really a world standard for names. Most people have names in the world, but they may have the same first name and last name. They may have only one name. It may be their first name, it may be their last name. It may have extended characters. It may not be representable in, the standard English character set or the standard Latin character set. And all of those things are very legitimate concerns. On the other hand, if you want to get a product out quickly that is mostly going to be used in the US, then you might decide to just not allow a lot of those name options to be used. You might just say, well, for the first version, we're going to insist that everybody have a first name and a last name, and that those names are all represented in Roman characters, and they're all shorter than 25 characters, or something like this. What I'm doing is I'm stubbing off all the handling of unusual names to just be, those aren't allowed. And maybe we can be nice about it. We can put up a little message that says we don't support that name, or whatever. But the point is, if I don't give that guidance as the product manager who's looking at the big picture and trying to make something happen quickly, a developer is never going to consider that stubbing off, or generally speaking, right? They're going to say, oh, I have to support names. That means names are these general things. There's one or two. There's many. They might be long. They might be different character sets. That's what I have to support. And so we have to provide that guidance of, oh, no, let's prune that off a little bit. That's not always true, and it's not literally true always in the case of the names, for example. But it's a type of thing that, as a product manager, you need to be thinking about, and it's because of the difference between the way that developers and product managers sort of think. It's a difference between our personalities. So one of the other things that, even if you are somewhat technical as a product manager, you've done some programming like in school or something, if you haven't really created production code, then there's actually a lot of stuff that the developers are doing that you don't even understand. This is an important thing to know. And it's useful to know that they're doing these things that are probably a little bit beyond your ken. And these are things like how to do exception handling, right? Because when you write your code in school, you make a lot of assumptions about the environment being, staying up and things like this. This is probably not quite true if you're a CS major, a computer science major, but if you've just taken a programming course, these are things that you probably didn't have to deal with. Things like exception handling, things like security, things like being able to be resistant to various kinds of internet hacks if you're doing software as a service or web-based application, making sure that somebody can't do SQL injection into your address form and things like that. And of course, robustness in general, making the software really hard to break or unbreakable as possible. Those are things that are they're tedious. They're not about creating features. They're about making really strong infrastructure. They're often not recognized, and they're usually skills that, as I say, product managers haven't really done much about. They might have specified some of these things, like it must be secure, right? But in terms of how that's actually implemented, that often, at least I believe, especially for non-technical product managers, that is something that you're not going to know much about. Now, another set of areas where I sort of have some tips for product managers, particularly if you're non-technical, is that you need to, the things that I think are most important to get a grasp on if you're a sort of non-technical person are things like the architecture. Meaning, what are all the pieces that go into your product? Like if you're a web-based product, there's usually a back end and there's a front end, and there might be an application server in the middle. And it's really helpful to understand those, and maybe even to be able to know more about some of the details about what happens in each of those. You don't have to know, again, how the coding works. You typically don't even need to know the technology, although as you learn more about this, you learn about different kinds of web servers and Apache and Tomcat and Java and JavaScript and whatever, all the programming languages. Those will become familiar, but you don't really need to know that stuff because the level of decisions you make as a product manager typically don't have anything to do with that technology type of thing. Occasionally you'll be called in to help with a technology decision. How should we build the new version on the existing stack or on the new stack that has these characteristics and has these components in it? Well, typically, even then you're making the decision not on, well, is Java better than Ruby on Rails, but you're making the decision based on, well, how fast can we get value to market? Can we get developers who know it? How robust is it? Does it perform well on the types of loads that we're going to have? Things like that. Really not related to the technology itself at all, but just essentially how well the technology works for what you're trying to do. So, again, the details versus the big picture. I mentioned this on the previous slide as well. Just understanding that our role is really a big picture role, but we sometimes have to dive into details. But we have to restrain ourselves from getting too far into those. And sometimes it's really desirable. I mean, even me, I don't consider myself a programmer, but I am a technologist. So I often find these technical details very interesting. But really, most of the time, they're a waste of my time. And I'm not going to make a better product decision if I go down into the weeds of the details. That is almost always true. It's not always true, but mostly that's true. And it's something that we have to, particularly as the more technological product managers need to manage that themselves. There's also a sense that systems are unknowable. I was talking about this to a coaching client yesterday, and he said, or one of the things I was guiding him about the personality of these developers, is that oftentimes the developers are very expert in the area of their product, of their component, but they might not be expert at all in the other components in the system. That's certainly true at my company. There are 4 or 5 different fundamental components of the system, and the people that know the front end, for example, don't really know anything and would be totally lost if they had to work in the back end. Or in some parts of the back end. Some parts of the back end they probably know a little bit about, and some parts of the back end are totally mysterious to them. And there's some folks that work in the middle part of the back end, and they can't work on the far part of the back end, so to speak. So systems are, you can't just tell by looking what's going on. There's always a lot of magic happening. And the people that are experts in the particular layer understand that magic and they grok it, but they don't necessarily grok what's going on in the systems around them. And so in a sense, this is meant to make you think, oh, in that sense, they're just like me, right? I don't understand what's going on at any level in great detail. They typically understand what's going on in 1 or 2 levels, but not every level. So it's just something to know, right? In a sense, they're not like us. I also mentioned that there's a lot more to programming than what we learn in school. I already went through that. So let me quickly talk about some of the technical concepts that I think are actually really useful to know. And this is not a full list, but it's a few of them. And I actually did podcast. I think there's a video too on YouTube of some of these sort of I talked about 3 or 4 of them to introduce, and I'll do sort of drill downs on other sets of these technical concepts, but this is sort of the list that I'd be working off of to do that. So let me see what's going on. I'm going to type a little note. Any questions? Oh, so if you have any additional questions or want me to expand on any of these topics, you can put a note into the chat window, or the what is it called? Yeah, it's chat. For the video, and I will answer your questions if I see them. I'm having a hard time figuring out how to lay out my window so I can see all of them, but we'll cross that bridge when we come to it. But anyway, let's talk about a few of these technical concepts to know or to learn. So I talked about the repository. It's a way of thinking about that's where the data is. And oftentimes the repository also contains things like relationships between data, or it enforces relationships, and what's called data integrity, meaning that there's only one copy of the data, and there's a well-known copy, and there's not multiple copies and things like that. So the repository concept, pretty valuable. I'm going to explain exactly about what a thin thread is. That's the question that came in. So then there's this idea of front end and back end. So I mentioned that already as an idea of the architecture kind of thing. And the front end is typically the user experience, the user interface layer. So if you're thinking about a web application, that's the stuff that shows up in your browser. And then the back end, or the database, is where all the data lives that the browser shows you. And there might be more than just 2 layers. There might be a middle layer as well, often called an app server. And that is a place where, so the database stores the data, the app server does some calculations on data that it pulls from the database, and it sends it to the front end to be displayed or to be interacted with by you. So it's just a good, I would be surprised if you didn't already know this concept. Obviously, since most of our development teams use some form of Agile, and typically it's Scrum, it's really good to know something about those. Now, I recommend reading the article that I've written called What to Tell Your Executives About Agile to get a better perspective on Agile than typically you get from most Agile trainings, and certainly from any Scrum trainings. One of the problems that can happen, particularly in a big company that makes an Agile transformation, is that Scrum becomes an end in itself, and it doesn't, which almost always makes it stop delivering on the value that you were hoping to get from Agile. And that's certainly, I've seen it happen over and over again. And typically what the reality is that a company that's going to be successful with Agile, particularly if they're of any size, is going to be doing something that might be related to Scrum, and they might call it Scrum, but it's not really going to be Scrum, because Scrum itself is not, it's easy to see if you sort of analyze it. It's not really scalable for big product type things. The concept of order of magnitude and also what's called big O notation, that's related to how big or complicated something might be, or how the impact on performance of something. And it's essentially just an idea of, how many things are we going to have to process, and how fast are we going to get through those things. And so the order of magnitude, of course, is orders of magnitude are powers of 10. So you can think about, a million is 3 orders of magnitude larger than 1,000, because it's 1,000 times 1,000, and 1,000 is 3 orders of magnitude. It's 10 to the 3rd power. So I'm not going to go into great detail on the definitions of these, but these are really useful things to learn. The idea of an API, which essentially, for the purposes of being a product manager, is really mostly about it's about 2 parts of your application, or your application and some other third-party application, have to communicate about things, like they have to pass data between. And typically they're going to do that with what's called an application programming interface, or an API. And basically what that just means, the way to think about it, is it's just the way that data passes. And the benefit of a good API is that it makes it relatively easier to make changes, like, I can change some functionality in this application that I use for this thing without impacting this other application, because I'm doing all my communication via an API, and the API is not changing. And that's essentially, it allows you to have a level of independence, but still have these connections. And so many, many well-known systems have APIs that mean any software can interact with them and get data in or put data out. You know, if you know Jira, for example, the bug tracking system, and the agile. It's now really more of an agile system than a bug tracking. I'm showing my age. Jira started as a bug tracking system. Anyway, now it's an agile system. But the point is that it has an API, so you can have an application. If you have a project management application, your project management application can, if somebody creates a task in your application, that can be sent to Jira using the API to create an issue in Jira. And it can be created in a specific place and so on. So that's what APIs do. Architecture is just sort of the organization of like that front end and back end thing I mentioned. It also can be thought of as the functional blocks of what happens in your system. Often that's called a marketecture, the functional block diagram that has layers, and each layer has multiple blocks in it. So it's a good concept to understand. And often it turns out that understanding the architecture can really help you with some decisions, like knowing where particular things in your application happen within the architecture can help you make decisions about how to improve those, how to remove them perhaps, how to replace them. Those are all useful things to know about the architecture. Optimization is a really interesting one. One of the things that developers like to do is optimize their code. One of the things that product managers should resist is optimizing code, because it's very easy to optimize code or do what we often call pre-optimization, optimizing the code before we know whether it needs to be optimized. You have lots and lots of code in your application, and there's a few parts of your application where the performance of that code is important. Where if you can make the code faster, it will create value for the customer. And there's hundreds of places in your code where optimization will not have a very significant impact on the customer, if any. And so spending time optimizing the things that don't impact value is a waste of time. And so it's really good to wait to optimize until you've actually figured out what parts of the code need optimizing in such a way that will create value for the user. So that's why optimization is an interesting topic. As I say, developers love to optimize because it helps make the code more elegant. It helps make it it's making it faster. It just might be making it faster in a way that's not important. Heuristics is a concept around understanding how the process works. And the way that I think about it, it's sort of an abstract understanding of how a process works, or a way to get something done without necessarily knowing the theoretically correct way to do it. It's a topic that comes up a lot in programming and computer science and stuff like that. Worth learning about. Probably actually not quite as useful as some of the other things that I'm talking about. But it's one of those things that's useful to know. A thin thread is this really great concept that I like, and I've heard of a lot of other interesting takes on a similar concept. I'll link to an article by a guy named Gojko. I don't know his last name. I think he's Serbian, but I could be wrong, but I'm pretty sure it's Serbian. Anyway, he has a concept of a skeleton or a walking skeleton, but it's a very similar concept. The idea of a thin thread is you have an application. You're working on an application or a big feature or a module or something that sort of does a whole set of things that supports and there's a flow that goes from front end to back end. And the idea of a thin thread is to make the simplest possible front end, the simplest possible middle, the simplest possible back end that you can show the data flowing in a very easy, simple case from the front to the back and then back to the front to show that it can do something. So the idea of the thin thread is the whole application itself is a big block. A thin thread is just one little thin path through the thing. It's sort of a happy path through the whole thing to show that you got all the different pieces kind of working together and communicating effectively, even if they're not doing anything like all the functions that you want them to do, right? So an example of a thin thread, if you were talking about a feature to capture a user's address in order to ship something to them. Well, a thin thread might be, well, can I get their name and get the name through the middleware into the database, and I have the name in the database, and I can then print out a label, a shipping label that has their name on it. That would be a thin thread. Obviously, that's not that valuable of an application as it stands, but it shows that I know how to connect all the pieces. And then in the front end, I add, well, let me get the name and the address and the city and the zip. And then let me put that through the middleware and put it in the back end. And I already know that I can do all of those components. Now I just have to expand that. And then I can print out an address label. And then maybe I want to say, well, I also want to collect the credit card. And I want to collect the secret code on the credit card. And I want to hide that, with little asterisks when they type that. So that's another little thin thread. And that gets passed in. And then we have to add another little thing that's like, can I validate that credit card? So I have to call out using the credit card company's API to validate the credit card. And then I print the order, and so on and so forth, right? So that's the idea of the thin thread. It's just the simplest thing you can do that, the simplest thing you can do to sort of show that you can get all the way, that there's actually a possibility of achieving the thing that you want to do. That's the full vision. And it's related in some ways to the concept of the minimum viable product, which I am not defining here, which I should, but I'm not. I probably should do a whole video about the minimum viable product, but that's another thing. So I talked a little bit about corner cases, and so the idea, and of stubbing. So the idea, remember the example of the names, I might consider a person with a single name, with just one name, as a corner case, and I might just say I'm going to stub that corner case off. Now, some corner cases you have to handle. Some of them are significant. What if the person entered a credit card and they're declined? Well, that's in some sense a corner case. The happy path is that the credit card is valid. But in this case, the corner case is the credit card is declined. So how am I going to handle that? It's not that cornerish. It happens a lot. Another one might be, oh, this credit card is marked in some way that we should report on it. Now, that is a real corner case. And it might be we choose not to do that. Or it might be we choose to just launch an email rather than trying to do some other kinds of processing. Frameworks and stacks, this is related to the technology, typically the technology stack, and frameworks usually refer actually not to the technology stack itself, but to the UI layer of the technology stack. So there's several famous technology stacks, well-known ones. There's the LAMP stack, for example. Linux, which is an operating system, Apache, which is a web server, MySQL, which is a database, and PHP, which is a programming language that are used to connect all those things together. It's actually a little bit, we've sort of moved beyond the LAMP stack lately, but there's other stacks, like a lot of production organization, a lot of people making real software for real production, particularly for enterprise software, use Oracle as a database. They use Apache and Tomcat as the middleware. They use Java as the programming language. So that's another stack, a typical stack. There's the Microsoft stack, which is Microsoft SQL Server, typically the Microsoft programming languages, so the .NET environment, and then the Windows OS as the operating system that supports all those things. And so those are the examples of stacks. It's useful to know what stack you're on because it impacts a lot of things like what developers do you get. It also may impact. There's a lot of potential impacts. It's just good to know what it is, and over time you'll learn what the differences are. Now, typically, I've always worked at companies that worked in something like the LAMP stack or that Oracle stack, but some people work only in companies that have the Windows stack. Now, if I try to interview for a job at a company that had the Windows stack, they might say, well, you don't know our stack, and that would be true, and they would say, how can you help us? And I would probably be able to tell them a story, but they would probably still be biased against me. That's all I can say, because I haven't worked in that stack, even though I'm a product manager and that the stack shouldn't be that important to me. Frameworks are typically these UI things. So like there's a framework called Angular, which is a framework that has buttons and things. There are some older frameworks, like I don't even know the frameworks, to be honest. Angular is one of them. There's a bunch of them. And I'm not going to list off the names because I can't remember them. And then there's the concept of metadata, which is the idea of data about data. So if you think about, think about you go to Amazon, you make an order. And so the data about your order, if you go to Amazon, is that you ordered a particular thing. So the thing that you ordered, your address, your name, your credit card number, those are all data about the order. But there's also metadata that Amazon might be collecting, like what time of day did you make the order? What other things have you ordered? And so we can then recommend to you some other things. There might be metadata that it infers about Amazon infers about you, well, for example, things like what computer are you using? Are you using a Macintosh or are you using a Windows computer? And so those are all sorts of things that can be considered. Now, metadata is also data, and the slope between metadata and data is slippery. Sometimes you can consider a thing data and sometimes metadata, but it's useful to know this concept of metadata. It's data about the data. And so you can think about, well, what do I know about, what do I know about this customer that I can then use to maybe make some better decisions about how I present something, and that's what Amazon is doing when it says, things like other people who bought this thing you're buying bought this other thing. Or it might say, oh, I recognize you. I'm going to look at your old orders. That's metadata in the context of a visit, and tell you and suggest maybe you order something that you already bought before because we know you like it. So that's the idea of metadata. And then Heidi also mentioned on the notes on the chat, client-server architecture. Yeah, this is an interesting one. It's old at this point. Client-server architecture is a concept that was really popular in the 80s, and then it kind of fell out of favor in the 90s because of the web. But the web is also really client-server architecture in some sense, except that in the 80s, the clients were what were called thick clients, meaning that they had a lot of processing power and a lot of knowledge and code in the client side. So the idea of client server is I've got a server, sort of a database that's supplying the data to me, and then I've got a client that is taking that data and doing interesting things with it. So, it's a fairly straightforward concept of architecture. In the client server world, originally that client was very smart. And the database didn't do very much processing at all. Most of the processing was done on the client, meaning on your computer. In those days, we didn't have laptops. We just had desktop computers, or we might have even had mini computers that did the client server part. And the point was that there was this processing power on our desktops. And so we would get the data from the database, and then the client would do a lot of work, and then would send back the answer to the database to be stored. Well, nowadays in the web, the architecture looks similar, right? Because there's still a database, there's still a client, but the client is now what's called thin, meaning it doesn't have much processing in it. Some of these frameworks that I mentioned, these UI frameworks, give you a little bit more processing, but mostly the frameworks are used for processing that's solely associated with the presentation of the data, as opposed to things you do with the data. And so typically now we have this 3-tier architecture, which is the database in the back, and then the middleware, like the app server in the middle, and then the client, the thin client on the front that's really just responsible for presenting the data. So that's one of the differences between client server and our current model, which is essentially the Web 2.0 model. So there's a bunch of technical concepts out. I want to spend a lot more time on that than I kind of intended to. Let's talk about the other thing. So that's sort of technical stuff that helps you deal with developers, right? But then there's some soft skill stuff, and I want to talk a little bit about all the soft skills that are related to working with developers. And the fundamental thing to remember is that the developers are human beings, right? And so they're motivated by many of the same things that you are motivated, or that I am motivated by. And in particular, this concept of mastery, autonomy, and purpose is from the really great book called Drive by Dan Pink. Highly recommend any book by Dan Pink. All of his books are good. But Drive is really good because it's about motivation and sort of the new science of motivation. It's now probably around 10 years old, actually. But the ideas are still there. And so the point is that there's lots of research about what motivates people and what types of incentives are good for motivating people and which types of incentives are not. And it turns out that most incentives are not good for motivating people, as it turns out. But the research shows that really there's 3 things that help people become intrinsically motivated, meaning that they don't need outside motivation, that these 3 things, mastery, autonomy, and purpose, give people intrinsic motivation to do a good job, to be productive, to step up, to be in a good mood, to be happy, things like that. So what I wanted to do quickly was talk about what mastery, autonomy, and purpose means in the context of a product, and in specifically for product developers. So, mastery is that your developers are experts in what they do, and that thing that they do is problem solving. And so in order to support them in recognizing and showing their mastery, or enabling them to, what's the word I'm looking for? There's a word. Enabling them to demonstrate their mastery, I guess is what I want to say. You don't give them a solution to a problem. You give them a problem. And if you give them a problem, there's a lot of good side effects of giving them a problem as opposed to giving them a solution. For one thing, they're probably better at finding solutions than you are. Another thing is they're probably going to look at multiple solutions before they choose the right one. As Einstein said, and this is a great quote from Einstein, if he had an hour to solve a problem, he'd spend 59 minutes. If he had an hour to come up with a solution to a problem, he'd spend 59 minutes understanding the problem and 1 minute solving it. And this is sort of what you want your technical people to be doing, is looking at the problem, not looking at the solution that you hand them and ask them to build it. So there is this question, what if you are an expert yourself? Meaning, what if you are a developer as a product? And lots of product managers are developers. But the point is, it's not your job anymore to be the expert in solving the problem. Your job as the product manager is to find the problem and to give it to them. And you also have to help them in a really specific other area, and it relates to some of the personality differences we talked about earlier, which is your role once you give them this problem is to help them find a good enough solution as opposed to the perfect solution. And this can always be a challenge. Developers, they look at a problem and they say, well, I can see how to solve this in a perfect way, or I can come up with the perfect architecture, but that thing may be way too expensive to build, and it may be overkill for what you really need. And so this is an area where you have to be very careful, while enabling the developers to demonstrate their mastery. You have to also be careful not to let them overdo things. So that's mastery. What about autonomy? Well, this is really just you shouldn't tell them what to do. You can ask them to solve a problem, but this is sort of related to micromanagement. It's related to telling them how to solve the problem when really they're supposed to be the experts at that. And so really they're better at that stuff than you are, and you can't guide them to be better at designing or better at coding. They can get guidance from their colleagues potentially for that. And that's sometimes a benefit of doing things like what's called team programming and things like that. But it's not your job to do that. Your job is to say, here's a problem, here's the constraints and the boundaries of the problem, and now go give me a good solution. And then bring me your ideas, bring me your design, and we can talk about it, because I might not have articulated all the constraints that I want you to meet. But their job is to find the solution. Yours is to bring them the problem. And then, of course, purpose. Why? They want to know why that you're asking them to do this thing you're asking them to do. And this can be several different things, right? It can be, why does this make my customer's life? Why does it make our customers' lives better? Why does it make our company more successful? How does it make me more successful? Not me, the product manager, me, the developer. How is this going to help the developer become more successful in their career? That's even something that they are actually motivated by. So those are some of the topics that are some of the ways that I would think about motivating, developers if you're working with them, while not being a technical person yourself. So, final thing. I probably left out a lot of open questions about working with developers if you're not technical. And so at this point, I'm just wondering if anybody has any questions or comments on things I might have left off of this. It went everywhere. It was probably not the most organized presentation I've ever given, but I think I covered some interesting things, and I'd love to get your feedback on this. If you like this video or you felt it was valuable, of course, please click the like button, hit the share. Feel free to subscribe to my channel. what I do with a lot of these videos, I do two things. One of them is I often turn them into sort of more professional looking videos, meaning that I take out all that part where I wasn't sure anybody could hear me. And I put on a little bit better of an introduction and a little bit more of an outro. The other thing I often do is I turn them into podcasts. So you can look at my podcast, which is alltheresponsibility.com is where the podcast is. The name of the podcast is All the Responsibility, None of the Authority. And so that's about it for the live show tonight, unless anybody has any questions. And even if you're not watching live, if you come up with questions as you're watching, definitely feel free to add them to the comments. I always notice the comments and I reply to them. And I either will take your question and turn it into an answer in the comments on this video, or I'll create a new video like I did today for Heidi. So Heidi, I hope you enjoyed the video. It got a little wacky at moments, but I hope it was useful for you and answered some of your questions about how technical do you have to be. And if you have additional questions, certainly reach out to me. You know where I am. And to everybody else who has questions and things, you know where to reach out to me as well. You can reach out to me here on the YouTube site via comments. It's pretty easy to figure out my email address, but I'm going to tell you it's nils@nilsdavis.com. You can go to my website, secretpmhandbook.com, and you can buy my book about product management. And I talk a little bit about the personality types of product managers. I actually don't talk about in the book the personality types of developers. That's not in the book because the book is about product management. But hopefully this was useful for you. Anyway, that's about it for today. I'm going to stop the stream now, and hopefully you found this useful and interesting. And I look forward to seeing you next Monday. I do this every Monday night at 7:30 p.m. Pacific time, and over time I will get better at it in terms of the technology, so I know what I'm streaming and stuff. This whole YouTube thing is kind of a little bit annoying, but I'll figure it out. Anyway, talk to you soon. Bye-bye.